are on page, well, it's not actually page 28. It's the page with notes where you took notes yesterday on oxidation rules. So the reason for these rules is so you can tell what is oxidized and what is reduced. So you're looking at an equation and you're looking at all the oxidation numbers that you just got done writing down and practicing in the quiz. And what you want to remember is this. When something is oxidized, the oxidation number goes up. The oxidation number goes up. In other words, if you had something that the oxidation number was 0 and it changed to +2, the oxidation number went up. And we would say that that is oxidized. Also, we can kind of remember that because it means loss of electrons. That's what really makes the oxidation number go up. And we have an acronym that helps us remember that. LEO, like Leo. Leo, that's loss of electrons is oxidation. Loss of electrons is oxidation. And the oxidation number will go up when that happens. So make sure you have those 3 bullet points. What is oxidized? It's when the oxidation number goes up because there's a loss of electrons. And we often remember that with LEO, Leo. So what is reduced? Well, reduced is when the oxidation number goes down. That even sounds like reduction. So that's like if you had an oxidation number that was +4 on the reactant side and it changed to +2, that means the oxidation number went down. So what that means is you gained electrons with that particular element. So that is a gain of electrons. Remember, we're gaining negative charges, so the oxidation state is going to become more negative. Does that make sense? So, there is an acronym for this, and it is GRR. Leo goes GRR. And what that means is gain of electrons is reduction. This is the common way that people remember that loss of electrons is oxidation and gain of electrons is called reduction. So, I'm going to write an overall reaction here at the moment. And I'm going to choose this reaction, and then I will do an oxidation half reaction and a reduction half reaction later. And so I'm going to change to a color of black at the moment because I'm not doing either reduction or oxidation. This is the entire reaction. So I'm going to write it all the way across here, and then we'll look at oxidation and reduction in this reaction. So here's the overall reaction. Please copy this down. 2 iodide ions, that's iodide with a charge of -1. You can always look that up on your common ion sheet and confirm its charge. This next ion may not be on your, may be on your common ion sheet. I'm not sure. S2O8. And it has a charge, as a group, it has a charge of 2 minus. And then there's a chemical reaction. And in this chemical reaction, we produce iodine, and iodine is one of those magic 7 that's always diatomic. Diatomic means 2 atoms, diatomic. And it also produces 2 sulfate ions. That's SO4 with a charge of 2 minus. So the next thing we have to do is go through this, and we're going to spend some time assigning an oxidation state to each element in each compound. And I'm going to do that in orange. Yep, going to do that in orange. Of course, for iodine, that's going to be a -1. And you can either write this above or below the species. Because the charge of a ion, a monoatomic ion, is the same as its oxidation number. Now, I'm going to remind you, rule number 5 up there was the sum of the oxidation numbers in a polyatomic ion is equal to its charge. So here, we have a polyatomic ion, and the sum of its oxidation numbers is equal to its charge, so it's -2. So when we add all of these oxidation states together, it'll come out to -2. So we have 8 oxygen, and you remember that the oxidation state, I'm just going to go back to writing them up above because that's what I'm used to doing. The oxidation state is, it doesn't matter where you write it, but I need more space down here. 8 times -2. What's 8 times -2? 8 times -2. That's 16, only it's negative. -16. Now, what can we add to -16 to give us -2? 14. Yeah, and this takes a little bit of practice to just get it immediately, but you'll get there. 14 minus 16 equals -2. That is our key to finding out what the oxidation number is for sulfur. Now there are 2 of these. 2 times what is 14? 7. Thank you. So this oxidation state is 7. So we've got all the reactants. Let's go over and do all the products now. We're back to iodine, which is 0, because we had a rule yesterday that said elements in their pure state have an oxidation state of 0. Right? Is everybody okay with that? Now we're going to look at the sulfate. We're going to go to this ion, and we're going to look at its total charge is 2 minus. So that means the sum of the oxidation states for sulfate is -2. So we've got oxygen. Oxygen is 2 minus. What is 4 times 2 minus? -8. -8. What number minus 8 is equal to -2? Plus 6. Plus 6 minus 8 is -2. So the sulfur here is plus 8. So we've now finished assigning oxidation numbers to each element in the entire chemical reaction. So what we're going to do next is we're going to do the oxidation half reaction. So that's what we're going to do next. That's what's right here, is the oxidation half reaction. And I want to remind you, up here written in green, so I'm going to go back to writing in green. No, I'm not going to write in green yet. We're looking for an oxidation number that goes up. In other words, we went from -1 to 0. Do you see that the oxidation number went up? It increased. So that is what we're going to write. The stuff about iodine is going to go into our oxidation half reaction. So we're just continuing showing that reaction down here where we have 2 iodide actually. We have 2 iodides that change into I2 with no charge. But wait, there's more. Notice the charges. The charge here and the charge here should equal out, which means we need some negative charges. So what are we dealing with that are charged negatively? Electrons. How many electrons? 2, because then we'll have -2 charge on both sides of our oxidation half reaction. So this entire half reaction that we just sketched, that is called the oxidation half reaction. That's the oxidation half reaction. Next, we're going to go to the reduction half reaction. And in the reduction half reaction, we are looking for the element that gained electrons. In other words, the oxidation number went down. Do you see anything where the oxidation number went down? I see where my mistake is. Do you guys didn't holler out my mistake? Notice this +6 here. That should be the same as the +6 on sulfur. And I'm looking here going, what was it that went down? Oh, we got to fix that. If you didn't get that mistake fixed, this sulfur was +6. Does everybody get that changed? The sulfur we calculated is +6. So the thing that went down was the sulfur. I need to get my blue highlighter back again. The sulfur went from 7 to 6. The sulfur went down. So our reduction half reaction will have the sulfur going down. But we're going to write the entire species here. Sorry. And I'm going to write it in red to keep with my oxidation stuff up above. So the S2O8 that had an overall charge of -2, I'm going to put the 7 here just to help us keep track of what changed. I'm going to scoot this all over. Oh, computer, why did you do that? Okay, I'm not going to change it. I'll fit it in. Okay, it changed to, do I still have a red pen? It changed to SO4, 2-, where the sulfur, good thing we're almost done, where the sulfur changed to an 8. No, it didn't. No, it didn't. No, it didn't. What did it change to? 6. And my pen is... There we go. It changed from 7 to a 6. But you'll notice there are 2 of the SO4s because there are 2 sulfurs. So we have to balance the charges. So those 2 electrons are going to come over here. 2 electrons. Of course, electrons have a negative charge. There we go. So I hope you've noticed here that if something is oxidized, something else has to be reduced. If something is oxidized, something else has to be reduced. You can't have one without the other. So if you come across, oh, I had 2 things getting oxidized, you probably have a mistake, because if something is oxidized, something different has to be reduced. Now, we have just a little bit of room here. You still have room on your paper? Okay.